let's get started. So thanks so much for the invitation to
Yes.
share the health assessment for lakes with you. I wanted to acknowledge that this work was done in close collaboration with the Lake Ecology Unit. And today I'm going to be giving you some background information on our approach and some details on the scoring. And then, as Jen mentioned, Kevin Krause is going to be doing a live demo to show the application in action. So just double checking that you're seeing what I want you to see. You folks are just getting my slide, correct? So,
Yes, we're seeing your first slide.
Yep.
There we go. Great.
All right. And before I get into describing the WHAF for lakes, I just wanted to circle back to some key concepts that we apply to all of our WHAF products. We kind of focus on this idea of managing for system health. So these key concepts are kind of central to our understanding of natural systems. And we start by defining health and then addressing the complexity of the system and then thinking about delivery across a range of spatial scales. So the original WHAF application was developed around watershed boundaries and focused primarily on flowing surface water. And we always felt there was this unmet need to represent lake health in a way that would also apply the 5-component system and connect it to watershed health. So, there's so much data about individual lakes, but it seems that it isn't always shared by representing different spatial boundaries or the context of the lakeshed and watershed connectivity that we thought the WHAF could provide. So as I said, we partnered with the Lake Ecology Unit to create an interface that would complement the WHAF. We started by defining lake health as a system that's near its natural state with self-sustaining plant and animal communities and human communities that are invested in protecting it. And an unhealthy lake as a system that has more disturbance that it can handle, lower resilience, so likely to decline in the future. Then we use the available data to look at different aspects of health, deliver those as scores, and develop an interface that lets the user pick the spatial scale that they want to use to compare lake health. Those scales range from the catchment upstream, a county, a major watershed, or a basin. And it really feels like that emphasis on delivery by spatial scale is a little bit unique, and it can bring that subset of relevant data to our managers and decision makers. One of our biggest surprises, I think, has been the amount of interest that one of our target audiences, those lake associations and individual landowners, have had in the application. I mean, Minnesotans really do love their lakes. So we've been getting emails and phone calls that ask questions and let us know that people are really engaging with the material. So that also led to kind of a quick turnaround. If you looked at this early on, we did make some changes recently to better clarify our messages and methods. So we're going to show a little bit of the information that's available in this application. But before we do that, I'd like you to watch this and encourage you to look for ways that you could see this information help you do the work you already do. These are some places where we think it might be helpful. We've already started some conversations in some of these areas, but at the end, we're hoping to have enough time to discuss some of those ideas. If something comes to mind, maybe you can drop that idea in the chat and we can circle back to that at the end. So to open the WHAF for Lakes app, you can go directly from our main application. Kevin, if you want to drop those links in the chat, we could do that. You can get there directly from our page, or you can use the link to go directly into the WHAF for Lakes application. And it will open a page that looks like what you see on the left here. But before we navigate to a place, I also wanted to point out that there is a menu system in the upper right, and that holds a lot of important information. I don't want you to miss that. That link that's highlighted says lake details. That's where you can put in the name of a specific lake or a DAO number and go directly to your lake of interest. The use guide holds a lot of detail on how to move through the application, and also how the scores were created. And the About page has kind of the concepts and definitions that we use to frame the application. So I did want to point out a few things in that use guide resources. Here's kind of a quick overview of what you would see there. As I say, navigation tips, information on the components and the scores and the grades. And then I wanted to dive a little deeper into this hierarchy. So as you move through the application, there's a lot of information that is delivered there, but I wanted to share this idea that the scores build up from the metrics. Those are combined into index scores, and then those are combined into component scores, and the mean of the three components then become that lake health score. And we have also decided to convert the lake health score into a grade. You may also notice that, like, if you're familiar with the WHAF main and that idea of the 5 components, that you only see really those 3 of those components called out here. Aspects of geomorphology and connectivity that are kind of missing in the structure are actually reflected in the Lake Watershed Index and the Score Your Shore input. So that's how we're handling those components currently. There may be some enhancements in those areas down the road. Quick shout out, some of our data partners are listed there. In particular, that University of Minnesota Lake Browser Water Clarity was a good connection to make, as well as MPCA and DNR data that's brought to the table. This is just kind of a conceptual example of how we have talked about all those metrics on the previous slide might help us widen the lens of considerations and broaden the conversation about what influences lake health and how the lake is responding. This is another example of how we try to think across spatial scales, so you can apply that perspective to understand more about the dynamics for an individual lake. This can also be a nice little crosswalk for us to the main WHAF application to introduce watershed conditions that might be influencing this lake that you can dive into in that application as well. So again, thinking about traveling through that hierarchy from metrics to the scores to the overall health grade, this graphic is showing all of the overall scores at a statewide spatial scale, and then the component scores at that scale as well. If I didn't mention it, there are just shy of 3,000 lakes that have scores at this time. So each dot in this graphic represents a single lake and puts those individual values into the perspective of a statewide distribution. Okay, and all those overall scores are then been converted to health grades. So this is a kind of description of percentages of lakes that fall into each category and some general thoughts on how those grades might inform managing a resource. We also need to remember that the grade is just a snapshot in time for lake health based on the data that we have right now. So that was my quick background piece, a summary of some of the concepts that inform the approach and some of the background on how the data has created scores. So I'm going to turn it over to Kevin, and he's going to do a live demo showing moving through the application.
Hey, Beth and Kevin, I see that Denise Elston has her hand raised. So Denise, did you have a question? She's on mute, so we can keep going forward and come back.
Okay.
Thanks.
Can you see my screen okay?
Yes, thank you.
Okay, great. So yeah, a little demo here. So when we come into the application, we see first off this select an area, and the default here is set to major watershed, but we can also click through and go by county, etc. And to start this exploration, let's start from the point of view of if you were focused on a particular major watershed and we're about to dive into some one watershed, one planning work or attempt to do some priority resource ranking. And so let's go down. We're gonna pick on the Mississippi River Brainerd major watershed. And so right away, you'll see that the map changes on the left to zoom to that particular major watershed. The first load is sometimes a little slow, but it should go quicker as you go through. And so you see color coded on this map all the scored lakes within that in that outlined major watershed. And you can quickly pull up this. Oops, sorry. I had to click on this legend to show that what those colors represent as far as the lake health scores. And on the right, we can see all the scored lakes, a table with all the scored lakes within that area. And you can see the columns with some identifying information about the lake, as well as the scores. And each column can actually be sorted to start to look for patterns and relationships in these disparate data that have been brought together in a way that's directly comparable. So like if you were in this major watershed and you wanted to find the lakes with either the lowest health scores or the highest health scores, you can quickly sort by that. You can also dive further into each one of the component scores. So looking beyond the overall health score, are there any similarities across the major as far as water quality potentially, biology and hydrology. And then you can also do things like try and find if there's any commonalities or differences in similarly sized lakes. So can sort by this lake acreage. And then finally, all the way at the end here, I'll just also point out that you can quickly sort by those lakes that have listed impairments for them. And a reminder, you can export this as either an Excel or a CSV table to do your own analysis outside the application if you wanted to as well. And so now that we've kind of looked at that from a major watershed perspective, now let's imagine your focus is on already on a particular lake, and we can start looking at our lake details portion of the application. So first off, we're going to go ahead and pick on Bay Lake here. We're going to zoom to it. Again, this map will zoom to that on the left-hand side. And by clicking this link, that will bring up the lake details page for Bay Lake. And so what we've attempted to enable here is the ability to broaden your view beyond the confines of data related to just that one lake in a couple of ways. First, as you can see in the map here, we have enabled the ability to look at the lakeshed delineation quickly, so you can see the context for that lake, what landscape it's in. As well as you can broaden your view by seeing what's happening for other nearby lakes that are either hydrologically related nearby, maybe facing some of the same pressures. So to do that, you can see this Crooked Lake here is also scored. So if you wanted to go to that lake details page, you can quickly switch to that lake as well. But we're going to stay focused on Bay Lake here. So if we look at the summary tab, this is typically the best place to start. At the top here, you see some narrative text about what we mean by lake health. There's these expandable learn more dropdowns throughout the application. And so these will all show either information about, what a healthy lake is, how a particular data set relates to lake health, and how that can kind of shape our management and approaches to addressing that lake. And so you can scroll through that. At the bottom, there's also additional resources in some of these that you can take a look at. Then we have some quick descriptive text on how that lake health score is computed. And then here we'll see the lake health score for that particular lake, the grade that it gets, and then importantly, we can very quickly see how this compares to other scored lakes within that major watershed. So we see the mean for all those other lakes as well as the range of those scores. And then we can continue to dive in deeper to see the scores for the various components, as well as this kind of quick look at the component input status, which is an easy way to compare some of the metrics that contribute to these component scores and how they relate to regional goals or thresholds. Looking further, there are some lake basics, a table here that you can export, as well as a table that has all the data related to Bay Lake across the application that you can download independently. And then I also quickly want to, now that I've gone through the summary page, take you through one of these component pages to give you a little more familiarity on just the layout, because they're all fairly structured the same way, so that'll kind of help your navigations. So again, the component name, some narrative text. You can expand this, learn more. We'll also see that component score, the relationship to other scored lakes within that major watershed. And then we can start to dive into what makes up this water quality score. And as we can see here, this is an average of these phosphorus and water clarity index scores. So first, if you want to look at this phosphorus input into water quality, we see that you can quickly see that this is the first input into that water quality component score. And the data that we have presented within this, you can drill all the way down to the actual raw data that goes into this calculation. So in this case, for phosphorus, the score is based on the total phosphorus concentration for that lake, summer total phosphorus concentration, and how far away that is from that regional goal. And we have an additional set of data here. And so anytime you see additional data, that means that the data presented in it doesn't directly factor into our health scoring for the lake, but is maybe an additional resource that can also help inform our view of lake health and help in some prioritization and the like. This same structure continues then through water clarity, which is the second factor that goes into our water quality component calculation. And in this case, the additional data there is pulled from the University of Minnesota Lake Browser, that long-term water clarity data set from satellite-derived data. And then finally at the bottom, we can see one more set of information that's presented here, and that's all the listed impairments for that lake. And so again, this is a piece of additional data. This doesn't factor directly into our calculation of the water quality component or lake health, but is critical in any conversation of lake health. And so with that, I'll send it back to Beth with a bit more on how these scores and the compiled data that we present here can better inform how we think about lake health in kind of a usable way.
Hey, thanks, Kevin. Let's see. I am going to move forward here. I think. There, a little delay.
There we go.
Gotta love Teams. Yeah, so this is just kind of a summary of what Kevin just showed you on the water quality page. So I'm not really going to go through that again. Here is, if you go into the Bay Lake biology page, again, using those tabs across the top, similarly, right? You have a combined biology component score that's made up of 2 input scores. The first one is the fish community quality, and that uses the fish IBI. Again, you can see the threshold and then the deviation from the threshold that goes into creating that score. And the other input into the component score is the plant community quality, which is based on the plant FQI, the floristic quality index, which also has a threshold, and then the deviation for this particular lake from that threshold. So those, the fish community is kind of telling us whether or not we're meeting that expected abundance and diversity of fish species present, how well the community is kind of responding to the conditions in the lake and the lake shed. And then the plants are, those that are present that help stabilize sediment, assimilate nutrients, and create habitat. So we're kind of trying to capture different aspects of biology with those inputs. A couple additional data pieces, whether the lake does or does not fully support aquatic life use, and that biological significant class for each lake is also available here. And in hydrology, then again, a component score that has 2 inputs, the Lake Watershed Health Index that represents the anticipated level of impact on the lake from the level of disturbance that's in its lake shed. And the second input that is the relative risk from the condition near the lake, or that lakeshore transition zone that filters and traps sediment and nutrients. We use the score, the shore values for the condition of the shoreline, and aquatic zones. And again, some additional hydrology data is included here, including that watershed to lake area ratio that helps inform that anticipated contribution of groundwater flow. And then the last tab is stewardship tab. This page is a little different. There's no health score for stewardship. So it's not a component in the overall lake health score, but rather some additional information. Includes that benefit to cost assessment, if you've seen that before, that looks at the return on investment for a given lake. Additional information about some conditions and risks, including land use and cover, and then links to resources to help prioritize actions. So we're hoping to expand on this page with more of those resources to support users that are wanting to improve lake health. A couple other functions I just wanted to call out real quickly. We've been able to connect to Lake Finder. So if that's a resource you use, or you're in here and you want more about fisheries, or Lake Finder also often includes those water levels, you can click back and forth between the two. So we've coordinated with them to provide that linkage. And then that there's a button inside of the WHAF for Lakes map that will open WHAF main directly to the lake that you're investigating. So then, of course, once you open the WHAF map shown on the right, it's centered on Bay Lake in this case, and you can add, the different watershed boundaries, base maps, health scores, and other data layers. There's almost 200 data layers in the WHAF main that could be used for further exploration.